Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today, in one of our final trigonometry lessons, we will be talking about parametrics. So, what are parametrics? Parametrics are normal functions incorporating the aspect of time. Now, in STEM fields, this is used a lot because it's not just a graph, it incorporates time, which occurs and is thus very important when taking into account how things function and how things will unveil over time. So we will be graphing and finding out different x values, y values, and t values, also known as the time. Now let's get used to dealing with t values. So in this first part, we will be learning about eliminating the parameter and finding the rectangular equation. So parametric equations are written with x's, y's, and t's. We need to get them down to just x's and y's to graph them. Now, this means we must eliminate the parameter t. So we'll be given parametric equations will be one x equation and one y equation written in terms of t. Like it could be like t squared or like t minus 2, something like that. But we need to get it so it's just x and y so we can, graph it. Because we're given a function that is a parametric curve that's defined by two equations for x and y in terms of t. So what we do is we make a table, we plot the points, and depending on which one's easier, we get t in terms of either x or y, then we substitute that into the other equation, and we write that down, our final equation known as the rectangular equation. So parametric equations are just x and y equals in terms of t, and a rectangular equation is y equals in terms of x. So let's do a practice problem. So let's say we have the two parametric equations, x equals t minus 2 and y equals t squared minus 1. So for t in the interval -3 to 3. So first we put our t values, -3, -2, -1, 0, 1, 2, 3, because it's in that range. 4 statements, and we've all seen that in computer science before. But if you haven't, it just means that we'll be using t values from -3 to 3. It's simple, it's a domain restriction. So we plot that, and then we put our x and y values. Now x is just t minus 2. So it's going to be, this column is going to be all the values in this column subtracted by 2. -3 minus 2 is -5, -2 minus 2 is -4, and so on. We get -3, -2, -1, 0, 1. Now, y is just t squared minus 1. So these values are going to be those values squared minus 1. -3 squared is 9, minus 1 is 8, -2 squared is 4, minus 1 is 3, 0, -1, 0, 3, 8, so on. So we have these two columns in terms of that column, but now we want to get this y value column in terms of x. So what we have to do is we have to find t either in terms of x or y. So get a t equals equation. Well, y is dealing with squares, so we'd have to be dealing with radicals and all that, which is pretty hard. So the easier one just to do is find it in terms of x. We know that x equals t minus 2, so if we add 2 to both sides, we just get t equals x plus 2, as seen right here. Now, if t is x plus 2, and we have y equals t squared minus 1, then we can just substitute in x plus 2 for t, and get our equation of y equals x plus 2 squared minus 1, as seen here. And as we can see, it fits all 8 points as set by our table. Now, we just were given two parametric equations, and then we had to, based on that, we had to get a rectangular equation. Now we're doing it the other way. We're going to be given a rectangular or final equation and have to get the parametric equation. So let's say, what we have to do is we're given a y equals in a rectangular equation, and we have to write x and y in terms of t. So first, you just write x in terms of t, then you substitute. So you can do, for example, if we get the rectangular equation of y equals 3x plus 1, we can set x in terms of t, we'll just set x equal to t. Then we substitute x for t, because they're the same thing. That means they're interchangeable. And thus, our two equations are x equals t and y equals 3t plus 1. Now, there are really infinite solutions for pretty much every equation, because these two equations will get you an answer. But each equation, doesn't really matter what each equation is, because the other one makes up for it, in a sense, if that makes sense. So we could do one, for example, that says x equals t minus 2. Then to get our y equation, we just have to substitute in x. So instead of our equation being y equals 3x plus 1, we substitute in x, and we get t minus 2 as x. So 3 quantity t minus 2 is just 3t minus 6, and the plus 1 from up here, or 3t minus 6, sorry, and the plus 1 from up here gets 3t minus 5. So we just set x equal to anything in forms of t, and we substitute that in for x in our original equation. And make sure to put domain and range restrictions if they apply. They don't here, but if they did, you need to put them, or else you will get a point off. So here, though, like if you wanted to check my work, you could put these two equations and substitute them in. Any which way you do it, you will still get y equals 3x plus 1. Now, getting onto the heavy hitters here. Now we will be discussing application problems, specifically projectiles, because for application problems, it's just something is launched, find out a bunch of different stuff about it. So in order to graph them, though, and find out said information about the path of the projectile, you need three things, also known as your givens. The height of the object, written as h. The height of the object when projected. For example, if a ball was shot from a cannon 5 feet off the ground, then our height of the object, or h, would be 5. The initial velocity, written as v sub 0. Whenever you see sub 0, that just means initial. For example, the ball was shot out of the cannon at 50 miles per hour. Our initial velocity would be 50 miles per hour. When you're dealing with parametrics, you always have to write your units. For example, miles per hour, feet, degrees, anything like that. Now, the angle of launch, also known as theta, we don't have theta signs, we just have to write theta, that is one of the values you need. For example, if the ball was shot out of the cannon at 45 degrees, theta wouldn't be 45. So the two parametric equations are negative 16t squared plus v sub 0 sine of theta, all multiplied by t, and then you add h. Now, let's break this down. You add h because h is just the height when t is 0. If t is 0, then both of these things are going to be 0, because 0 seconds into its thrown just means before it's thrown will be h feet in the air. For example, if I have a ball, before I throw it, it's just the height of where my hand is holding it, and that's h. Now, v sub 0 sine of theta, that's what happens to the height based on time. But that is specific to this equation because it takes into account the launch and the angle. For example, it could go like this, or it could go like this, or like this. It could be any different angle. It could be powerful shot, not powerful. That's all going to determine the distance, the height, the time it takes for it to land, everything like that. Now, you see this negative 16t squared. That is actually going to be there in pretty much every equation because for a projectile that being launched in the air, that is the force by which gravity holds an object down. So when we're shooting a projectile in the air, it's going to be being pulled down by gravity by a factor of negative 16t squared. So every second it keeps increasing. And it's negative, so we know it opens downward also. Now, the equation for x. Now, the x value has nothing to do with the height because height is y value. So that's not going to be there. And gravity doesn't affect the x value because gravity pulls things down. And it is involved in a vertical plane when x is a horizontal. So we just do v sub 0 cosine of theta. Now, cosine, as we know, we use that when we're dealing with x or horizontals as in the equation for x, and the sine, we use that in y's or verticals. For example, the equation for y, and that's just stuff about negative 16t squared. So normally when you're given a parametric, you're going to be asked to find 5 things. The parametric equation in that model, which is the x and y parametric equations. So what you do is all you have to do is substitute h, the angle of the launch, and the initial velocity into the x and y equations that I just showed you. How long is the projectile in the air? It's going to be the positive t0, also known as the t value of the positive x-intercept. Because remember, in parametrics, the y-axis, the up and down axis, the y-axis is height. However, the x-axis is time in seconds. So the zeros are going to be when the height is 0, or is also known when it lands. So how long will that be? What will the time aspect of that be? Because when something is thrown or launched in parametrics, it's launched from the y-axis. So its distance is just going to be, well, its distance because the y-axis value, the x, or the time at the y-axis is 0, so it has no effect. When is the projectile at its maximum height? That's going to be the t value of the vertex, because as we know, in a negative vertex opening downward, the highest y value is at the vertex. So when, that when there means that we're trying to find a t value, a time when it's at its highest. So we're just going to find the t value of the vertex. However, if we're wondering the actual height, we just take the y value of the vertex, because the y value is just the height, and vertex is highest, so it's going to be the maximum height. Now, the fifth and final thing is, what is the distance it travels? So we know that t is time, y is height, but x is distance from the y-axis, also known as distance traveled. So we're going to have to find the x value. Now, the total distance traveled is just going to be the distance from where it's thrown to where it lands. So the t value of where it lands is the time it takes for it to from it. Okay, so if it's thrown, the time until it lands is the t value. So we just substitute that into our x equation to find the distance it travels, because t is time and x is going to be distance, horizontal distance. So if I throw it 5 feet, it takes 2 seconds. Then I just substitute 2 seconds into our x equation, and I'd get 5 feet. So now let's get started. Nolan Ryan throws a baseball with an initial speed of 145 feet per second. So we know that our v sub 0 is the initial velocity or speed. That's 145 feet per second. So at an angle of 20 degrees to the horizontal. So an angle of 20 degrees just means theta, or our angle, is 20 degrees. The ball leaves his hand at a height of 5 feet, so we know our h value is 5. It's 5 feet in the air before it starts. So we have to find the 5 things, the parametric equations that model the situation, how long the ball is in the air, when the ball is at its maximum height, what is said height, and what is the distance that the ball travels. So we know v sub 0 is 145, h is 5, and the angle theta is 20. So first, to find the parametric equations, we just have to substitute those values into the equation. So the equation for y is negative 16t squared plus v sub 0 sine of theta times t plus h. Make sure you enclose all this in parentheses, because you don't want to multiply all that together before multiplying by t. And then you add h to that. Now the equation for x is v sub 0 cosine of theta times t. Remember, y is sine, x is cosine. Now when we substitute in 145, 5, and 20, we get y equals negative 16t squared plus 145 sine of 20, quantity t, plus 5, and x equals 145 cosine of 20 times t. Now, part 2, what we need to find is, like we just saw, we need to find how long is the projectile in the air, which is, of course, the x-intercept, the t value of the x-intercept, which just means what's going to be the the first value, the x value. So if we need to find the t value of the x-intercept, then how are we going to do that? Well, we know the x-intercept, y is 0, so we can just substitute in 0 for y and get 0 equals negative 16t squared plus 145 sine of 20, well, multiplied by t, and you add 5 to that, plus 5. But I need to get the zeros. The negative 0 only matters for finding the vertex. It doesn't actually happen. It's really imaginary. So we have to find the positive t value. Well, how are we going to do that? What is that? You guys smell that? I smell a quadratic formula. If you haven't watched my video on that, please do so now, especially if you don't understand what it is. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we know that based on this, that a is negative 16, b is 145 sine of 20, and c is 5. So when we substitute that in, as you see here, we get negative 145 sine of 20 minus the square root of 145 sine of 20 squared minus 4 times negative 16 times 5 all over 2 times negative 16. And you put that in the calculator, and you get t equals negative 0.09774 and 3.19730. So we want to get our positive one, and we can round it because it's an answer. When you have answers, you're allowed to round. Just don't round when you're doing further calculations. We get the ball is in the air for 3.2 seconds. Now, I have a TI calculator, a TI-84, at my house, but it's kind of hard to show all that on a YouTube channel. But if you did have one and you were using it, what you want to do is you want to get the A, B, and C values. You want to hit the store button and hit the alpha key to store them as A, B, and C. And anytime you need to reference them, just use A, B, and C. So the ball is in the air for 3.2 seconds. Now let's go into the next part. We need to get the when and where, also known as the t and y values of the vertex. So, because if we're trying to get when it's at its maximum height, so that's just how long does it take to get from the y-axis to the vertex, which is just how long does it take to get to the vertex. So the vertex we know is the center of the two zeros. Look at that. We just found the two zeros. They are negative 0.09774, at which we add to 3.19730. We want to find the average, so we add them and divide by 2. We get 1.55. So the ball reaches its maximum height 1.55 seconds after it is thrown. So now we just have to find the actual height it is. So we substitute that t value into the y equals equation, because the only thing missing from the y equals equation is a t value, and then we know its height. So we get negative 16t squared plus 145 sine of 20, all multiplied by t, plus 5, because that's our y equation. And we know t is 1.55, so we just substitute that in. You get y equals negative 16, 1.55 quantity squared, plus 145 sine of 20, quantity 1.55, plus 5. And you put that in the calculator, and you get the maximum height of the ball is 43.439 feet. So now, our final part, we have to find the distance traveled by the ball. Now, as we discussed earlier, finding a height is a y value. Finding a time or when is a t value. But finding a distance traveled is horizontal distance from the y-axis, which is just where we threw it from. So we're trying to find the distance, which is the x value. It's going to be found by the x equation. So we know that the total distance traveled is just going to be the distance from the y-axis to where it lands. So it's just going to be the distance to where it lands, because the time it takes to get to the 0 is the time it takes to get to where it lands, which is the time it takes to go from being thrown to not moving anymore. So it's going to be the point where it's going to be done moving, meaning that the amount of distances traveled is going to be the amount of distance it will ever travel. So All we have to do is substitute the t value into the x equation. The x equation finds distance traveled after a certain amount of time. Time is the t value. So we know our x equation is x equals 145 cosine of 20 all multiplied by t, and t is 3.19730. So we just substitute that in. We get x equals 145 cosine of 20 multiplied by 3.19730. And that means the distance the ball traveled was, we put that in the calculator and find out the distance the ball traveled was 435.65 feet. So our answers, we have them here. We had to find the parametric equations, which we got negative 16t squared plus 145 sine of 20t plus 5, and x equals 145 cosine of 20t. And we got the ball reaches its maximum height of 43.429 feet, 1.55 seconds after it's thrown. And the ball was thrown 435.65 feet in 3.2 seconds. Okay, guys, thanks for watching. Please like, subscribe, and turn on post notifications. I'm Scholastic Sam. If you have any questions, comments, or concerns, please leave them down in the comment section below. Thank you to my math teacher, Mrs. Barrett, for teaching me all this information. She's a great math teacher. Thank you, guys. I'll see you next time. Goodbye. And always remember, knowledge is power.